Before I start today's notes, does the term completing the square mean anything to you from algebra last year? Completing the square, a method of factoring. Okay, I'm just trying to make sure my mind is in the right place for tomorrow's lesson. So I guess not. Completing the square isn't something that's familiar with us from algebra last year. So some, yes. Okay, so I'll take it. I'll start from scratch tomorrow. All right, I'll start from scratch tomorrow. No big deal. All right, so yesterday we talked about what happens when two chords intersect. Today we got to talk about tangents and secants. How's that diagram made up? What is CBA and what is EDA? Those are both what? What do we call those? You have a vocabulary term here for me. One, what do we call those, Meg? Two secants right here. Yep, these are two secants. And what's the next diagram made up of? A what and a what on diagram 2? 23? Good. That's a tangent and a secant. Excellent. Now, you may need to brush up, but all of us should be able to find angle A and B in both diagrams, I hope. Okay, angle A and B, because it's outside, right? All right, but that's not my concern today. My concern is what is the length of these? What's the length? And the easiest way for me to do this is not be fancy. It's to give you a saying of how to remember how to find the length of a secant or a tangent. And here's the saying. Whole times external. What's external mean to you guys? Outside. Yep. Well, outside. Whole times external equals whole times external. And I'll show you exactly what I mean by this saying for tangents and secants only. So go back to my first diagram. Name one whole secant for me. Using the letters I have up there, name one whole secant for me. 21? Either one. First diagram, name a whole secant. Doesn't matter. AC. So everyone ready? AC, whole secant times its external part. What are you going to plug in now? 21 again. What's the external part to AC? AB. There you go. So AC times AB is the same value as, give me the other whole secant now. 7? AE times its external part, which would be for us 8 DA. See how that works? Whole thing times the external part, go to the other whole times its external. Now, when we deal with the tangent, something changes just a slight bit. Let's see if anybody can figure that out. Let's start with the secant. Name the whole secant in this one. 3? Okay, so everyone ready? It would be DB times its external part. Keep rolling here with me. Good job. 2? CB. Now you ready for the tangent? What's the whole tangent? AB. And what's its external part? Also AB. So when we're dealing with the tangent, whole and external should be the same value. If you want to impress anybody want to rewrite this? Mahmoud? AB. Yeah, if you want to impress anybody. So that's what happens when you deal with the tangent. Whole and external are the same values. Before I move on, I got a question for you. There's one combination I didn't put up here. I did 2 secants. I did a tangent and secant. Griff, which one isn't up here? Why didn't I put 2 tangents up here? Did I just forget? No, I did not forget. Why did I not put 2 tangents on here? Tell me.
2 tangents drawn to the same point.
There's a theorem I gave you a couple days ago. I don't need a whole times external. They're always congruent. All right, so that's why 2 tangents are up here. Good. All right, you ready? Let's go. Dive right into this. Here's what I get nervous of before we do this one. You remember yesterday with the chords? Wasn't it segment times segment equals segment? Get that out of your heads. I don't want to see 5 times 10 equals 4 times x. Get it out of your head. Are these chords? Are these chords? No. So I'm not using that rule. These are two secants. Whole times external. Whole times external. Let's go. Give me one whole secant, please. I don't care which one. 22. Lead us off. 15 times its external part. Keep going. 4. 5. Now go to the go to the other whole secant. How do I write that? What's the other whole secant length? 12.
4 plus x.
Thank you for not saying 4x. You add things together if you want the whole. 4 plus x times its external part. External part 9. 4. Go. Whew. Just be careful of the directions. It does say if your answer is not a whole number, nearest 10th. So don't put the full 0.75 here. $14.8. Am I recording this? Yes, I am. Questions, comments? Tangent and a secant now. Tangent and a secant. Give me the whole secant length. 12 whole secant length. 11 times external. 3. 2. All right, what about the tangent? What's the hole in the external on the tangent? 22.
Y.
And y. Yep, always the same for the tangent. 22 equals y squared. Take the square root of both sides, and you're welcome for letting you guys round to the nearest 10th. Anything from you guys going? All right, can we stop with the baby problems now and go on to honors now? Can we go on to honors? That was just a little taste of the theorem. All right, let's go. 2 secants. Number 3. Give me one whole secant length. 8. Dig deep. One whole secant length. Good job. 8 plus y times its external point. Come on. 2. 8. Ooh, what about the other secant? What's its whole length? Come on. What's the whole secant length? Oh, 20.
Y plus 10.
Nice. Thank you. I usually get 7 plus y plus 3. That's good too, but let's combine your like terms. Y plus 10. And the external part. Woo. Oh, 1. 7. Six. You know how we had king size circle problems for the angles, right? We had a couple of those on the quiz. This is basically as close as I can come to king size circle problems as far as chords, tangents, and secant lengths. All right, because everyone see a tangent? Everyone see a secant? Everyone see a chord? All right, so I got it all in this diagram. I got it all now. So yesterday's in play and right now and today is in play. I don't know, what do you want to find first? Want to find y first? What's y? Tangent, secant, chord? It's a tangent, isn't it, Matt? It's a tangent. So I would have to do whole times external. I got a little bit of a problem if I have to do whole times external. What's my issue I'm going to run into if I have to do, ready? Whole times external equals whole times external. What problem am I going to run into real quick? Y times y equals something with an x in it. Not going to fly. So y is out. Could I find x though? Could I find x? Well, let's see. What's RP in this diagram? Chord. What is NM in this diagram? Chord. And they intersect. I think we have a theorem, don't we, from yesterday? If two chords intersect, how I can find the length of their segment. So let's start there. Let's solve for x first. Give me two segments on one of the chords. Give me two segments on one of the chords right now. Oh, 22. Good. 10, 3.2. All right, I'll get it out of the way. Fresh cut. Professional or homegrown? Professional. How much say did you get in it, Quan? All? Little? None? Okay. Are you happy with the way it turned out?
Yeah.
It's a little bit different for you. It's a little more Rico Suave ladies man than your previous cut. You didn't really have it parted down the middle, right? Got a little fluff to it too.
Wait, they said that it's because like my hair was super long. So it's like.
Is that usually, or do you have it long? Or is this like a once a year thing?
Like a once a year thing.
Really? So we're gonna go to next April before it gets cut again. And you don't mind it that long? Huh. Do you comb it now? No, really? That's just all natural right there. You just woke up and it looked like that. It's pretty darn good. It's pretty darn good. It looks very ladies man like. I like it. Rico Suave. Yeah. Do you like it? That's all that counts, right? Okay. No gel, no products or anything? That's amazing that you just wake up and it looks that great. That's awesome. All right, that's awesome. You taking notes, Mahmood? Yeah, exactly. How many times have you been telling me you're going to get that bird's nest cut?
I told you once. You've like called
I'm ready for something to just fly out and just be like, I'm ready to fight it.
I know that it's
because somebody's making a home in there. I don't know if it's a bird, a woodchuck, a beaver. I don't know, but somebody's making a home in there right now. So, all right, moving on. Sorry, 10 times 3.2. What about the other chord? What are the other two segments on the other chord? 22 again. 4 and X. Good. So we get X equal to 8. Plug it back into your diagram. And I think we can solve for Y now by doing whole times external. So for Y, I'll take care of Y squared, right? Y squared equals, what about the whole secant now? Now that I know X is 8, how long's the whole secant? 21? 18. And its external part, 19? 6. Regretting that I left the directions nearest 10th, especially on this one. This would have been a great number to break down, but hey, it is what it is. $10.4. So that's about as much as we can go with the king size circle problem. All right. This next problem brings me so much joy. Why does it bring me so much joy? because it's going to bring you so much misery. That's why. And I enjoy that. Okay, that's why. Got your calculators, by the way? You're going to need it here. Ooh, baby, you're going to need some calc action here. Doesn't look bad, right? It's just a tangent and a secant. How bad can this be? 10 times 10. How long is the whole secant ACD? Combine your like terms. How long is the whole secant? 24, whole secant?
Oh, wait, you want the other one? My bad. Sorry.
There's only the other one.
Sorry.
How many secants are in this diagram?
Alright, the whole secant is 2x plus 4.
Thank you. Times external part. 19? Yep. So we're off to a good start. 100 equals 2x squared plus 4x. We're fine. All right, your next move. Next move. What's up, Timmy?
Get the side to 0.
Get one side equal to, I see an x squared. Yeah, that's what I'm thinking. It's factor time, right? Get one side equal to 0. So let's move the 100 over. Okay, I'm just leaving it up there. Next. Serena, thought?
Can you, I don't know if you can do this, but can you divide out the 2?
As long as you divide it out of everything, yes.
Yeah.
Including the 0, which doesn't change anything, right? But yeah, you're basically taking a GCF out. But you're just dividing everything by 2. As long as everything gets divided by 2, yes, we can do that. Absolutely. So you guys are fine. Maybe I'm overhyping this one. 0 equals x squared plus 2x minus 50. I'll wait. What are you guys looking for now? What are you guys looking for? Is it a time to factor? X squared plus 2x minus 50. What are you looking for? Two numbers that do what? Yeah, multiply to 50 and are 2 apart. Anybody? Yeah, you're right, because we're going to be here a while. If you're going to tell me what the answer is here. There are not 2 numbers that multiply to 50 and add to 2. So we're not done with the problem and saying impossible, skip it. This has to be solved for x. If it can't be factored, you always have a go-to. No matter if it can be factored or not, you always have a go-to to solve for x. That go-to? Quadratic formula! Come on now! Let's go. I know you missed it. Be better than period 2. I was like, all right, where do we start? And they started giving me the distance formula. Be better. Be better. Be better. There was like x2 minus, I was like, absolutely not. There is a square root involved. Negative b. Plus or minus. Now your square root. B squared minus. Whether you can factor it or not, you can always use quadratic formula to solve anything with the squared in it. Okay, here we go. X equals, what's your b value up here? What's your b value right now? A, B, C. What's your b value? 2. When I plug it in, it's going to become -2, plus or minus. I do not want you to plug in anything. I want you to use your calculator and store. I feel much more comfortable when you store values in and figure it out instead of trying to do it on your own, no offense. What's your A value? What's your A value? So everyone hit 1. Your store button off to the left. And then I think it's alpha math, right? Is A above alpha math. Enter. So 1 is in for A. What's your B value again? 2. Everyone hit 2. Store. 2 store. Alpha, I don't know what it is. It's right next to math. They go in alphabetical order. Enter. And then finally, what's your C value? -50. Store alpha wherever C is. And then simply ask the calculator, what is B squared minus 4AC? Just type in B squared minus 4AC and it'll plug it in correctly for you. So none of us in here should get that number underneath the radical incorrect. And all of us are putting what 3-digit number underneath the radical? 204, hopefully. Anybody need a little calculator assistance here? 204. All right, still got to be all over what though? 2 times the A value, which is 1. 2 times 1, going to give me a 2. What's the directions here? Round to nearest 10th, right? It doesn't say simplest radical form, so don't waste your time trying to break it down. You know you're going to plug it into your calculator and round whatever decimal's there. How many answers should I get out here? How many answers? 2. A plus version and a minus version. So you ready? First one I'm going to type into my calculator. X equals, I'm going to do -2 plus radical 204 over 2. And you guys all have a fraction template, so go ahead. You can just plug all that in at once into your fraction template. Alpha y equals. And what do we get here? X equals, is this the 6.1? Round it to the nearest 10th, 6.1. And then how do I get my second answer now? X equals -2, but minus the square root of 204 over 2. And you end up with -8.1. Is that going to work on my diagram? No, it's not. Yeah, I didn't feel like using the X. Deal with it. Sorry. There you go. Better? Here you go. I'm eliminating. What's it remind you of? Come on. Easy. What's it remind you of? Yes, the smile French fries. Yes, thank you. Anybody? Yes? Definitely.
I used to have my Swifties and they stopped doing them.
You just get them. They sell them now, so.
But like
McCain's
Swifties were, like,
smiles. My daughters love those things. I don't know why. Well, how they're different than regular French fries because they smile. All good? Questions? What? Oh, do you want this instead, Jonah? It's eating the, so I can't accept it.
That's not what I want.
Oh, okay. Go ahead.
How did someone come up with this formula?
Good question. I don't know the history behind it.
They just decided they wanted to do this?
It was derived from somewhere, I'm sure. While you're working on number 5, I'll look it up. 5, Old Regents question. Old Regents question. Number 5. Yes, Serena.
Are you doing interview Wednesday?
We'll see here.
Are you gonna vote?
Yeah, I know. We got to take care of that as well. Look at that. Is actually derived using the steps involved in completing the square. Around 700 AD. Devised by a Hindu mathematician called, I'm going to butcher it, but Brahmagupta. So there you go. Mathnasium. Give me a break. There's no stopping the kids who's confident in math. Remember that. Go to Mathnasium. So there you go.
Mr. Carlino,
Yeah.
what do you like better, football or math?
Teaching. If there's a choice C. I'm not a big math. I'll be honest. I'm not like a big math doesn't like excite me. It's the teaching part. It's not the math part. Why did I choose math? Because that's the one that came easy to me when I was in school. So by the time it was, I decided I wanted to be a teacher, and I was like, all right, well, what am I going to teach here? Everyone basically is a PE teacher or tries that out. No offense to our PE teachers. Just everyone wants to be that. And I was like, well, now it's down to really chemistry and math, because those are the things I enjoyed when I was in school, and ended up being math. So it's not the math. Like I don't get it. Like I'm kind of excited, like how the numbers are related and how the answers come about. But other than that, I don't. Like it's not the math, it's the teaching. Yes, Mahmood, sure. I didn't know this became interview Wednesday for me. I already went, but go ahead.
When you start like screaming at a math problem, isn't that exciting? Like if that's not exciting, what is exciting, Mr. Carlino?
That's my version of getting you guys focused in.
Yeah, but
like we use quadratic formula. Sorry.
Okay, yeah, but like, what's you excited if that's?
I'm flipping I'm having the remote in my hand. I'm flipping through, and there's somebody says quadratic formula. I'm gonna keep flipping. Like I'm not going. Oh, girls, gather around! Quadratic formula. Sit down, Dad. No, that's not happening. No, absolutely not. No, Tammy.
I honestly have a feeling that if you did chemistry, you would break every single class.
I might, but so I decided on math, high school in particular, because let's be honest, me in an elementary classroom, probably not going to fly. It's currently, I can't tie my shoe. That's not my problem. Snot hanging down their nose. Have some self-respect. Use a darn tissue. Stop being soft. We didn't use the 4.5 here, did we? It's not whole times internal. Whole times external, right? And then the tangent x squared. This came out to be nice, didn't it? 100? Wow. So we should have got 10 out. All good? Stop this video because I've said enough.